morning, students. Now in semester 3 we are going to study the subject fluid mechanics and hydraulics, which is also called FMH. Now fluid mechanics and hydraulics. First of all, what do you mean by the word fluid? What is fluid? If you think what is fluid, then I think this comes in your mind that liquid is fluid. Okay, you are true, but in civil engineering only liquid is not the fluid. Fluid is any substance which can flow from one point to another point, that is called fluid. Okay, so in technically if you are considering fluid, then the term fluid include both liquid and gases. Liquid and gases both are referred as a fluid. Now we know that any matter in the world exists in 3 states. Any matter exists in 3 states, where first is a solid state, second is a liquid state, and third is a gaseous state. Okay, so is solid is a fluid, liquid is a fluid, and gaseous is the fluid. What is fluid? So technically we are considering liquid and gases as a fluid because that can move from one point to another point. So as we know that solid, if we are considering this solid, then solid is a rigid body. It has a fixed shape and fixed volume. On the other side, liquid and gases, in both liquid and gases, they are not rigid, no fixed shape and no fixed volume. So they can flow from one point to another point. As you can see, the liquid and the gases both can flow from one point to another point. So it is considered as a fluid. Now we studied the basic definition of fluid, which can flow from one point to another point, that is fluid. Now, what is fluid mechanics? Okay, the fluid mechanics is a branch of science which deal with behavior of the fluid. Here we are dealing with the behavior of the fluid. Fluid is liquid and gases or both. Okay, now we are going to study behavior of the fluid in rest condition as well as in motion condition. So now in a fluid mechanics we are going to study the fluid in detail at rest or at motion. Now there are mainly 3 branches of fluid mechanics, where first branch of fluid mechanics is fluid static, second is fluid kinematics, and third is fluid dynamics. Okay, in a fluid static, as we know that term static means steady. Okay, so in a fluid static we are going to study the fluid at rest condition. Fluid is at rest condition. There is no any movement in the fluid. Now in fluid kinematics we are going to study the fluid which is in motion. The fluid is in motion, where there are some forces acting on the fluid for the motion, but we are not considering the forces for that motion. So in fluid kinematics, fluid is in motion without considering the forces for that motion. And third branch of fluid mechanics is fluid dynamics. In fluid dynamics, we are going to study the fluid which is also in motion, but here remember that the forces for that motion are considered. We are considering the forces for this motion. So this is an image of fluid static. Here as you can see, this water is in steady condition. There is no any movement in this water. So if we study this water, that branch is called fluid static. Now here as you can see, the liquid is moving. There is a movement in the liquid. Liquid is in moving condition. Okay, but for this movement we are not considering any forces for this movement. So study of this liquid without considering the forces, that branch is called fluid kinematics. And now here, as you can see, the liquid is in motion. Liquid is in motion. But if we are calculating, then we have to consider the pressure force for this motion. So liquid is in motion and we are considering the pressure forces for this motion. That branch is called fluid dynamics. Okay. So now we are starting with our properties of the fluid. If fluid is moving or steady or any other state, then it has some properties. So now we are starting properties of the fluid, where very first property of fluid is mass density or density, which is indicate as rho. Mass density indicate as rho. So here mass density is defined as the ratio of mass of the fluid to volume of the fluid. Mass density is a ratio of mass of the fluid to volume of the fluid. Now we indicate mass as m and volume as v. So rho equals to m by v, mass of the fluid by volume of the fluid, and unit for mass is kg and unit for volume is meter cube. So unit of mass density is kg per meter cube. Now we are taking mass density of water. Normally for all the examples, we are taking mass density of water 1000 kg per meter cube. 1000 kg per meter cube, and mass density of mercury is 13,600 kg per meter cube. Okay, you have to remember these values. For water, mass density is 1000 kg per meter cube, and for mercury it is 13,600 kg per meter cube. Now our second definition is specific weight or weight density, which is indicate as small w. Okay, weight density is a ratio of weight of the fluid to volume of the fluid. Okay, so here weight density is a weight of the fluid to volume of the fluid, and unit of weight density is Newton per meter cube. Normally weight density W equals to rho into G. We are using this equation for solving examples, that W equals to rho into G. Now third definition is specific volume, which is indicate as small v. So specific volume of the fluid, it is defined as the volume of the fluid occupied by unit mass or volume per unit mass. You can easily say that specific volume is a ratio of volume of the fluid to mass of the fluid. Volume of the fluid to mass of the fluid. Now, volume of the fluid by mass of the fluid is the inverse of mass density, which is rho. So you can write down that V equals to 1 by rho, volume by mass. And unit, also unit is reverse, so unit is meter cube per kg, meter cube per kg. Okay. Now fourth definition is specific gravity. It is also called as relative density, okay, which is indicated as S. So specific gravity is defined as ratio of density of any fluid by density of standard fluid. Here we are taking standard fluid water. Remember that in this definition, the ratio of density of any fluid divided by density of standard fluid. So standard fluid is water. Specific gravity is a ratio of density of any fluid by density of water. And normally we take specific gravity of mercury 13.6. Okay. Now our first term, viscosity, property of fluid, which is very important to study, that is viscosity. Now what do you mean by viscosity? As you can see, There are 4 different types of liquid here: honey, maple syrup, corn syrup and dish soap. This all liquid are flowing with same velocity, as you can see, or not? No, they are not flowing with same velocities here, because different fluid deform at a different rate under the same stress. If we are applying the same stress here, different fluid are deform under different rates. The reason is viscosity, because viscosity is a property of fluid which offers resistance. Viscosity offers resistance or movement of that fluid. So this all 4 fluids are not flowing with the same velocities, and the reason is viscosity, because viscosity resists the movement of the fluid. And viscosity, like fluid with a high viscosity like honey or corn syrup, okay, deforms slowly than dish soap or maple syrup or water. So fluid here deforms slowly, have a high viscosity than the fluid which deforms easily. So this term is called viscosity. Now in viscosity we are going to study that Newton's law of viscosity. Okay, first of all, in this diagram, okay, see in this diagram that there are 2 layers. Bottom layer is flowing with velocity u. Here u indicate the velocity. U indicates the velocity and y indicates the distance. So bottom layer is moving with velocity u and top layer is moving with velocity u plus du. Both layers are moving with the different velocities. Bottom layer u and top layer is u plus du. Now distance between these 2 layers is dy. The vertical distance between these 2 layers is dy. Okay. Now when these 2 layers of a fluid at a distance dy move one over other, when 2 layers are moving one over other when different velocities, that is u and du. So the top layer, due to movement of top layer, it causes shear stress on bottom layer, and the bottom layer causes shear stress on top layer. Now due to these different stresses, that is created a shear stress. Due to difference of velocities, a shear stress is created here, and which we indicate as tau. So the top layer causes shear stress on bottom layer and bottom layer causes shear stress on top layer, and this shear stress tau is proportional to rate of change of velocity with respect to y. So the Newton's law of viscosity is tau proportional to du by dy. If tau proportional to du by dy, and if we ignore the proportionate sign, then tau equals to mu into du by dy, mu into du by dy, where mu is a coefficient of viscosity, tau is a shear stress which we called as force upon area, and du by dy, that is a rate of shear deformation. Now our next property of fluid is surface tension. We studied property mass density, weight density, specific gravity, specific volume and viscosity. We studied 5 properties here. Now next property of fluid, which is surface tension. Okay, I think you see this kind of thing. Any insect can walk on a liquid. I think you all see this in maybe rainy season. Any insect, a small insect can walk on the fluid, okay? Or a thin blade float on a free surface of the liquid. A thin blade, this thin blade is flowing in a free surface of the liquid. Or this small insect is walking on a water like it is a surface. Or rainwater comes into the earth into the form of circular water drops. Okay, so how it is possible? This is a circular water drop. How it is possible? Then any insect can walk on a free surface. So this is due to surface tension. That is our next property, surface tension. Okay, let's see what is surface tension. Now, in this diagram, consider that a container is filled up with water. A container of liquid, consider this container. Okay, now in this container, we are considering three molecules of water. First, molecule A, molecule B and molecule C. Okay, molecule A is in the water. So, molecule A is attracted in all the direction equally. All the direction by surrounding molecules equally. So, net resultant force on molecule A become 0. Now, molecule B. As you can see in this diagram that molecule B is on the free surface of the liquid. On molecule B, near free surface, there is unbalanced upward and downward forces. As you can see that there is unbalanced upward and downward forces. So, net resultant force is acting in downward direction. In molecule B, the net resultant force is acting in, remember this, downward direction. Same for molecule C. Where is molecule C? On a free surface. And on a free surface, every molecule, there are unbalanced forces. So, molecule C is also subjected to downward direction. Now, all the molecule on a free surface experiences a downward force on a free surface. Molecules on a free surface experiences some downward force. So, the free surface of the liquid act like a very thin layer under a tension. So, free surface of the liquid behaves, it is a layer under a tension. So, due to this tension, any insect can walk on this surface or blade can float on this surface. This is the reason surface tension. Because of this happened. Okay, the free surface is under tension. Due to that, it behaves like a thin layer. Okay, so surface tension is defined as a tensile force acting on the free surface of the liquid per unit length. Tensile force acting on free surface of the unit per unit length, that is surface tension. Okay, so this is our next property, that is surface tension. Now we are going to study that surface tension in liquid drop. Liquid drop. Okay, normally the liquid drop, we are considering a liquid drop or bubble in a spherical shape. The rainwater comes into the ground. The liquid droplet is in spherical shape. Okay, so first of all, in this diagram, consider this liquid droplet which is of spherical shape. Now, if we cut that from center, cut it, a water droplet from center. So, into this surface, a pressure force is acting, and at this surface tension is acting. So, there are two forces. First is pressure force and second is surface tension. The surface tension, as you can see that surface tension is acting on circumference, periphery, and periphery is pi into d. So, tensile force due to surface tension around the circumference is sigma into circumference, which is sigma into pi d. This is sigma into pi d. Now, pressure force on area, like pressure force in this area P. Pressure force in this area P, which is pi by 4 d square. So, pressure force acting on total area pi by 4 d square and circumference acting surface tension. So pressure force acting inward direction and surface tension is acting in outward direction. Now at equilibrium, inward and outward forces are equal. So we are taking equilibrium condition. These two forces will be equal and opposite, inward and outward. So sigma into pi d equals to P into pi by 4 d square. So if we are making subject P, then P equals to 4 sigma by d. So this is a pressure P, which is P equals to 4 sigma by d, where P is a pressure, sigma surface tension and d is a diameter of this spherical liquid droplet. Clear? So this theory is surface tension in liquid droplet. Now, so in today's lecture we discussed some properties of the fluid in detail. Now in next lecture we will study the remaining properties of the fluid. Thank you.